Okay, so our today topic is software defined Sd-Wan, software defined wide area network. Keep in mind two things. We have paper roadmap and another one we have a GPS navigation Google map which we are using on daily basis. I will give you one analogy. Suppose you are traveling by car or maybe by walk or whatever in any city, suppose from Manchester to London. This is your target. It can be in any place, in any country. So in old days, we were using a paper road map. You have printed road map and you are going from one place to another place. Now you don't know in advance that there is a road closure or not. You don't know that there will be a delay or not, there is any accident or not, because you have a paper map and you are going through that paper map. But you can face many issues. Maybe there is an accident, maybe the road is closed, maybe for any whatever the reason can be, but we don't have any alternative until we reach there. Then we can decide to change the path, or maybe there we don't have any path to change. It can be. So this is the old paper road map. Similarly, we have the traditional WAN. Like still many companies are using traditional WAN and we are reaching to the internet, and if there is any issue the internet link will be down. We don't have any backup plan and we don't know, maybe there is a slowness. Similarly, these two definition fit to the SD-WAN and traditional WAN. Consider SD-WAN like a GPS navigation, recent Google map. When you are traveling by one place to another place, so you can easily find out that where is a closure, where is a road closure. Even you know the traffic. If there is a red line, it means there is a huge traffic. And you know each and everything. How long it will take to reach there, and you can find each and everything. While in road map these things are not available. You are not aware of these things in advance. So this is the fit example for SD-WAN and traditional WAN. So it means if you are using navigation GPS, so you can easily find out road closure, accident, travel delay and insufficient routes, and you can change in advance to any other route. Because this navigation software is using satellite, where you can know the real time road map and everything. Similarly, we have SD-WAN edge routers which we can use for WAN, for centralized control and management, and we have more than one WAN. If one WAN has any issue, it will be switched over automatically. That's why it's called SD-WAN, software defined wide area network. This solution is for wide area network. Similarly, SD-WAN will help us if there is any jitter, there is any packet loss, there is any delay and there is any latency, like a GPS system, which they can avoid road closure, accident, travel delay. Similarly, SD-WAN can help you in jitter, packet loss, delay, latency and so on. And it will tell you in advance and it will automatically switch over if you configure them like that way, even though you can configure manually as well. So basically, multi-connection WAN solution is called SD-WAN and FortiGate firewall. If you combine more than one link, ISP link, WAN link to work together, is called SD-WAN and FortiGate firewall. And today word is very important. Why is important in today words? Because nowadays every company has software as a services such as AWS, Azure, cloud application, cloud services such as Office 365, and all those things are now on the cloud. And we want to access those things frequently in every organizations. And maybe you want to access internet. Keep aside these things, even though this is best fit for the cloud solution. So we need such solution, and that is Sd-Wan, Software Defined Wide Area Network. Now what you can do, Sd-Wan is a virtual interface basically in FortiGate firewall, which group member up interfaces. So basically it's combine more than one interfaces in a group, we call them Sd-Wan. And minimum is 1, it means you can combine 1 as well. And maximum 255. And you can group them. Now after when you group them, so you will use this Sd-Wan and your group and your firewall policy rather than the individual interfaces, because now you combine them, so it's better to use. And definitely we will use the Sd-Wan logical interface in our routes and also in our firewall policies. So it means these interfaces are the member of Sd-Wan zone, which we group them. And then you can use various balance algorithm, which we will see in the lab. So what you can do, you can apply many load balancing methods, such as by source and by destination, by source and destination. Also there is many methods available to choose based on such as bandwidth, such as best cost, and also you can do it manually as well, which we will discuss a bit later. So it means we can create maximum 4000 Sd-Wan rules. We will discuss about Sd-Wan rule a bit later. And also health monitors. We will discuss health monitor related to Sd-Wan as well. This is just introduction to Sd-Wan and FortiGate firewall. So as I told you, Sd-Wan is a software defined approach to manage wide area network. It's a software based, that's why we call them software defined. Software will take the decision based on the criteria, and we can use this for the underlay and also for the physical. Now we will apply health check and Sd-Wan rules as per our expectation and as per the business requirement, what they want. This FortiGate firewall will automatically and intelligently change the route based on your criteria, based on your Sd-Wan rules. You can use application, you can use internet services, and whatever you want. As I told you, even you can manually define that always send traffic to this Sd-Wan member. So this is Sd-Wan. So Sd-Wan are is higher capacity bandwidth, centralized management, and network visibility and multiple connection type. These are the benefit. The top benefit of Sd-Wan are higher capacity bandwidth, because we combine them and we can distribute the traffic on both, and we can send the traffic when one is down, it will go to the other link is down, it will go to the third link. and we can do all the thing from centralized management to one location. We can manage all these links, and we will see the visibility of all these links and all these multiple connection. Now to configure SD-WAN we need a zone. So it means SD-WAN is divided into zone. Basically, when you put those ISP interfaces, we call them SD-WAN zone. Suppose you have two ISPs, maybe you have more than two ISP. You need to put and combine these ISPs link in a zone. We call them a zone, such like a zone in any firewall which we create. When we combine something, we call them a zone. So these member interfaces are assigned to this zone, and zone use in policy and static route, as I told you before as well. So it means it will logically grouping these ISP link, and then we can use the zone in our firewall policy as a source and destination for more control. And definitely SD-WAN member cannot be used directly in the policy because we combine them for such purpose. Now we will call this SD-WAN zone in the policy rather than individual member, and also in static route as well. So now we know zone is basically combined interfaces. Which interfaces? Your ISP link interfaces, such as ISP1, ISP2, which connected to your FortiGate firewall. You combine them and put them in SD-WAN zone. You give them any name, suppose SD-WAN, and this is our zone. Now the advantages I already told you. SD-WAN is a way to remove high cost, low speed connection from your location and replace them with lower cost, high speed connection. It gives you flexibility, and it provides you better bandwidth utilization and secure connection. Definitely it will save money and time as well, and is scalable. Now what is SD-WAN member? SD-WAN member are also called interfaces. Your ISP interfaces are called SD-WAN member. Either those port or interfaces which you use to run the traffic, to take the traffic and combine them in a zone is called SD-WAN member. And at least one interface must be configured for SD-WAN to function and work. I told you, you can combine up to and FortiGate up to 255. Minimum one is required in a zone, and that interface is called member of the zone. Another thing which we will use in practical lab related to SD-WAN is performance SLA. Performance SLA also called health check. Basically, performance SLA will check the link, the quality of the link. We already use in Cisco as well SLA for health monitoring. So if there is any issue, if the link is failed, if there is the quality of the link is not good, maybe there is a jitter, maybe there is a delay, maybe there is any other issue. So which thing will recognize these interfaces? We call them SLA. So it means when the SLA fall below configure threshold, the route can be removed, and this is the job of the SLA. The threshold which you set, that if the delay is that much and if the jitter is that much, so what to do? Remove this interface from the routing table and the other link will be used, the different link which you combine them. And you can use many options for the SLA, such as maybe you want the quality to monitor, maybe you want to check the latency and jitter, packet loss, and maybe if the link is fail or not detect of not reachable, so it will be removed from the routing table and another interface will be used. So this is the job of SLA and SD-WAN. We can monitor one or two target server. How we can use this SLA? Suppose you have two ISPs link, so you can set WAN1 and WAN2. Suppose these are the two ISP link. What you can do, you can ping a server 88 continuously from WAN1 and WAN2. If it is not reachable, either it is slow, either there is a jitter, either there is a packet loss, change the link to the other one and remove that from the link. Suppose WAN1 is reachable in 1 second and WAN2 is reachable in 10 seconds. So definitely WAN1 is the best link based on the quality and bandwidth. So what they will do, they will remove WAN1 and they will forward the traffic to WAN1. So this is the job of the performance SLA. We can set ping, we can set HTTP, and there are more other protocol which we can set for checking through CLI, but these two are available through GUI. Graphically you can use ping and you can use HTTP to check some server so that you can decide which link is the best one. So this is the job of performance SLA and SD-WAN. Another thing related to SD-WAN is rules. Rules is called services, and rule control path selection. Which path will be selected? You need to create the rules. Specified traffic can be dynamically sent to the best link. Either you can specify manually as well. So these are rules in SD-WAN. Suppose if you say that if the source is this one and destination is this one, use this link. This is called rules of SD-WAN. So the outgoing interface is of your WAN link, which is combined and which is the member of SD-WAN zone. You can create rules for these interfaces and you can decide the criteria to use the best link, maybe by bandwidth, by jitter, by delay, and whatever you can do dynamically or statically, it's up to you. These are called SD-WAN rules. So SD-WAN rule match the traffic and then implicit rule apply. Suppose when not SD-WAN rule match, so there is top to bottom they will check these rules. If none of the rules is hit, what they will do, they will apply implicit rule. There is one implicit rule as well. So it's like a policy route. And in these rules we can identify the traffic and specify the outgoing interface for it. And these rules will be checked, as I told you, such like a policy from top to bottom. And the first match apply first fit. If no rule match, the default use SD-WAN rule. There is a default rule that will be used. So you can create a rules to select the best link. This is the simple way SD-WAN rule. Now before going to lab, we need to know some terminology. The first one is bandwidth. So bandwidth means speed of the link or interface, or bit per second is called bandwidth. Either bandwidth is the capacity of the link. Either how many bit we can be sent over the link per second is called bandwidth. It means number of bits that can be transmitted in a single second is called bandwidth. So it's like a pipe, how much water can go in 1 second. So you can analyze and you can check the capacity of the pipe. So similarly it's a bandwidth. Another terminology is congestion. Congestion basically causes delay and latency. It's like a traffic. When there is a huge traffic, you can call them congestion. Congestion is, suppose there is a huge packet coming, there is 1000 megabit per second coming, but the outgoing is 100 megabit per second. So definitely there will be congestion. And suppose you have a aggregate interface is 100. So it's become 500. while there is 100 outgoing interface. So what will happen? There will be congestion. Similarly, you have 1000 megabit per second LAN, but the outside WAN is going 100 megabit per second. So definitely there will be congestion. And congestion will cause delay and latency. Now coming to what is delay. Delay or latency refer to the time it takes for a packet travel from source to the destination. It means delay or latency means time when the packet take from one source to destination. There are two type of delay, fixed delay and variable delay. Maybe fixed delay is similar every time. Fixed delay is a specific amount of time for specific process take. All the time it will take that one. Such as how long it take a place a bit in the transmission media. So definitely every time it will take the same time. And variable delay take unspecified amount of time and affected by factors. It can be by many factors. It can take maybe once it take 10 seconds, next time it will take more than 10 seconds or less than 10 seconds. So this is called variable delay. So there are two type of delay. Now coming to jitter. Jitter means variation of the delay of received packet. It means difference between the delay of the IP packet is called jitter. Variation of the delay of streaming application is called jitter. Let me explain you. Suppose this one is packet, every time it's taking same time, suppose 2 seconds, 2 seconds, 2 seconds every time. Now jitter means this packet take 2 seconds, next time is take 10 seconds, next time is take 30 seconds. So this is variation. This variation is called jitter. Even though jitter is also type of delay, like here I told you, delay repair means time it takes for a packet to travel from source to the destination is called delay. How long it will take from source to the destination. If it is taking same time every time, suppose you are going to office on daily basis and you are reaching your office in half an hour a daily basis, but for some reason next day you take 1 hour because there was an accident, so you take more time and reach to office. Next day again you take suppose 40 minutes, maybe there is a road closure, so every day you take different time to reach office. It means this is called jitter. Uneven packet arrival time is called jitter. Unarrival of you to office, sometime you take 30 minutes, then 40 minutes, 60 minutes, maybe 10 minutes, 15 minutes. So this variation is called jitter. And then definitely latency. So latency means the packet, data packet to reach to the destination from the source is called a latency. Either the time between two execution of events is called a latency. Either process message at both source and destination end is called latency. It means process and the delay generated in the given network is called latency. Either time up it take a packet to travel from point A to point B is called latency. Either the round trip, suppose you are going to office and from office to home, how long you will take, so this is called a latency. You take 20 milliseconds to reach your office and then 25 milliseconds to reach back to your home. So when you combine this, so it means 45 milliseconds is called latency. And sometimes one side we also call them latency, suppose 20 milliseconds. So from your office to home is called latency. Either the round trip, when you reach to your office and come home, so definitely this combined time is called latency. Another terminology is packet loss. Packet loss, as I told you, if you have any issue, the above issue, definitely your packet will be lost, and router and switches and your network, and definitely those packet will be lost first, which is sensitive, such as real-time video, voice, those will be dropped first. So this is called packet loss due to delay, and maybe due to jitter, or maybe due to bandwidth, and whatever, it can be many reasons. And it is reached to the destination, and maybe it's failed to reach to the destination, and maybe it's lost and some of them reach. So this is called packet loss. Finally, we need to discuss Sd-Wan strategy. There is many strategy: manual, best quality, lowest cost, and maximum bandwidth. And manual mode, if you are using manual mode, no health check are used. We use manual strategies to select the preferred interface, as I told you. Which strategy you need? You can define that manual and you say send the traffic to WAN 1 all the time. If WAN 1 is not available, send to WAN 2. That's it. This is what you decide. Maybe you can decide that send this traffic to WAN 1 and send this traffic to WAN 2. So no need of health check. This is called manual strategy. There is a best quality. Best quality mode, choose the best link to forward the traffic. It will compare them by cost, and a link cost factor is specified. It can be latency, it can be packet loss, and so on. And based on these criteria, it will choose the best quality link, and they will forward the traffic to that link. So this is like a dynamic. You can use best quality strategy. It can be by latency, jitter, packet loss, downstream, upstream, bandwidth, and they will decide the best quality strategy, and they will send the traffic to that one. Similarly, lowest cost SLA strategy. It will choose the lowest cost link that satisfy SLA to forward the traffic. Here you need to define the SLA, and based on that SLA, it will choose the best link based on your SLA. Suppose the interface that meet SLA target is selected. It means the interface with lowest assigned cost, if there is a equal, so definitely the cost equal, they will choose the lowest cost possible, which is 0. If there are multiple links with the same lowest cost. So you can use lowest cost strategy as well. And finally, a maximized bandwidth SLA strategy. So you can use definitely SLA based on load balancing algorithm. And based on load balancing algorithm, the one which is pass the criteria, which is SLA, they will choose that link. So here you put them both the link and the link which require SLA target, and they specify the load balancing algorithm, they will choose that one. Finally, SLA targets. You will see these value. Latency threshold, we discuss latency. Latency SLA to make decision in millisecond. By default is 5, and you can maximize, you can put different value in millisecond. So latency threshold, this is the threshold. If the interface pass this threshold. Jitter threshold. So jitter threshold is also by default 5 millisecond, and to make a decision, so you can put the jitter threshold. And packet loss threshold is in percentage. By default is 0, and you can put, suppose 1% traffic is dropping, so the threshold will be passed and they will take a decision. Check and link status, so check interval, the interval in which the FortiGate check the interface in millisecond. Default is 500. And this is failure before inactive. The number of fail status checked before the interface show is inactive. By default is 5. And restore the link. When the link will be restored. So by default is 5. These values are here. Check interval. And failure is before inactive, and restore the link. So it will check after 5, restore the link. By default is 5 check. And they will check the link. If link is 5 times available, they will restore them. and this is if the fail, so they will check them, and this is the interval in millisecond. And finally this option will remove the route from the routing table if that is not available, if the link is not satisfy the criteria, and when it's available they will put them in the routing table back. So these are the theoretically stuff related to SD-WAN which we discuss, and the next video we will see practically SD-WAN configuration and FortiGate firewall.